Charlie left his mother's house traveling at an average speed of 36 miles per hour. His sister Sally left 15 minutes later traveling the same route at an average speed of 42 miles per hour. How long before Sally catches up to Charlie? How long, right? That's ultimately the question. So we're looking for time, or in this case, times, right? How long before Sally catches up to Charlie? There are two unknowns in this problem. One for Sally and one for Charlie. So what I'll do is I will let's let C represent the time that Charlie was driving. And that time, let's put that in terms of hours, since we see that we have units of miles per hour. And similarly, we'll let S represent the time Sally was driving. And that will also be in hours. We are told that Sally left 15 minutes later. Sally left 15 minutes later. All right, so let's find an equation then for the idea of time in this problem. If Sally left 15 minutes later, that means that Charlie's time was Sally's time plus 15 minutes. Now, we can't use 15 because our units are in hours. So we have to remember that 15 minutes is the same as 15 minutes per, so converting that to hours, 15 minutes over 60 minutes per hour gives us 1/4 of an hour, or 0.25 hour. So Charlie's time is Sally's time plus 0.25. Now, what else do we know? We know that Sally catches up to Charlie, which means that their distances must be the same. So let's come up with an equation for distances. Well, recall that we know that rate times time is distance. So if the distances are the same, let's come up with an expression for Charlie's distance. Charlie's distance is rate times time. Charlie's rate is 36. Charlie's time is C. Similarly, Sally's rate is 42, and Sally's time is S. So we have a second equation here working with the distances. So now we have a system of equations. Here's the system. And we need to solve the system using whatever methods we want. Now, since I see that I have one equation where one of the variables is already isolated, I'm going to use a substitution. I'll take the S plus 0.25, I'll take this, and I'll replace the C in the other equation. So I now have 36 times, instead of C, S plus 0.25 is 42S. Applying the distributive property, 36S plus 36 times 0.25 is 9, and that's 42S. I'll subtract 36S from both sides. And so 9 is equal to 6S, and dividing by 6, we find that S is 1.5. If S is 1.5, then we can solve for C. C is S, which is 1.5 plus 0.25, 1.75. So what's the conclusion? How long before Sally catches up to Charlie? Sally's time is 1.5 hours. So Sally will catch up to Charlie when Charlie has driven for 1.75 hours and Sally has driven for 1.5 hours.